Here's one of the strangest facts in all of physics. Take two objects in space, a star and a planet, the Earth and the Moon, and let gravity pull them together. Isaac Newton solved this completely over 300 years ago. Two bodies trace a perfect, predictable ellipse, looping forever, and you can calculate exactly where they'll be 1,000,000 years from now. Now add just one more object, three bodies, all pulling on each other, and everything falls apart. There is no formula, no equation that tells you where they'll be. This is the three-body problem, and it has haunted mathematics for centuries. Let's start with what works. Two bodies locked together by gravity. The math here is gorgeous. Newton's law of gravitation plus a little calculus gives you a clean, closed-form answer. The two objects swing around their shared center, sweeping out smooth ellipses, exactly as Kepler had noticed a generation earlier. Give me their starting positions and speeds, and I can hand you their exact location at any moment in the future or the distant past. The two-body problem is solved forever with a single tidy equation. Predictable, elegant, finished. So you'd think three bodies would just be a little harder. It is not. When you write down the equations for three objects tugging on one another, something breaks. The motion becomes tangled in a way that no clean formula can ever capture. In the 1880s, the great Henri Poincaré set out to prove that our solar system was stable, and instead discovered the exact opposite. He showed that for three bodies, no general solution exists, no master equation. The paths loop, swing, and fling each other across space in patterns that never quite settle and never quite repeat. And here is the truly unsettling part. The three-body problem is chaotic. That means it is exquisitely sensitive to where you begin. Take two copies of the same three bodies and nudge just one of them by a microscopic amount, less than the width of a single atom. For a little while, the two systems look identical. Then they begin to drift. And then they diverge completely, ending up in entirely different futures. This is the butterfly effect, discovered decades before anyone gave it that name. Even with perfect equations, the tiniest uncertainty at the start explodes into total unpredictability. So, is it hopeless? Not entirely. We can't write down a formula, but we can hand the equations to a computer and grind out the motion, one tiny step at a time, though only for so long before the chaos catches up and our prediction dissolves. And hidden inside all that chaos are a few perfect, impossible gems. Special starting conditions where three equal bodies chase each other forever along a single figure-8 loop, beautifully balanced. This one wasn't even discovered until the year 2000. Rare little islands of order floating in an endless ocean of chaos. So that's round 23, and this time something different happens. For once, math doesn't just shrug and walk away. It hands us a brutal, beautiful answer. For three bodies in gravity, no perfect formula will ever exist, and the future is, in principle, unknowable. Brain, 0. Math, 22. And round 23, math finally takes the point by proving that some things can never, ever be predicted. Subscribe. The whole streak is linked from the start, and trust me, the chaos is only getting started.